So two different ways to do the same problem. We could try this one other way. Let's give it a shot. On both of those problems, I used double angle identity for cosine that was 1 minus 2 sine squared theta up here. I'm going to try to use one of the other two and see if we can get that to work. Okay, so instead of immediately plugging in 1 minus 2 sine squared theta for cosine of 2 theta, I'm going to try a different one. Let's try, it really doesn't matter. Let's try cosine squared theta minus sine squared theta. So I'm going to plug in sine 2 theta equals 2 sine cosine. And I'm going to use cosine 2 theta equals, say, cosine squared minus sine squared. And we'll see if that works. Okay, so things look a little bit messier in this case, but let's just keep our pencils moving and see what happens. Oops. I'm going to distribute the negative sign. Now I know what you're thinking. There's a cosine squared plus a sine squared, so we can cancel that to 1. The problem with that is the cosine squared has a negative sign on it. So we actually have negative cosine squared plus sine squared, which isn't our fundamental trig identity. Oh, I don't know, but what can we do here? We could go ahead and multiply both sides by that denominator if we wanted to, and hopefully things would simplify. Another option would be to maybe try to substitute the fundamental trig identity, the cosine squared plus sine squared theta equals 1. You wouldn't be able to substitute that in directly, but maybe what you could do is say, oh, I know that cosine squared is 1 minus sine squared, and then you could plug that in right there, just for the cosine. So a couple different options. Again, no matter what you do, as long as you're not making algebra or trigonometry errors, you should be okay. I'm just going to multiply through the denominator and see what happens. Okay, big parenthesis on the left-hand side, I'll distribute. And then somehow the left-hand side and the right-hand side should be equal. Now we have 3 terms on the left-hand side and only 1 term on the right. So I'm going to work with the left-hand side and see if we can reduce the number of terms over there. Maybe this would be a good time to turn everything into sine and cosine. Maybe. Let's take a look. Let's see what happens. Oops. Cotangent is cosine over sine. Okay, so we haven't done anything illegal. We haven't done any algebra that isn't true, so we should be okay at this point. What can we cancel? Well, the only thing, unfortunately, that we can cancel on the left-hand side is one sign with one of those signs in the numerator. Of course, we could multiply the cosine and the cosine to get cosine, the cosine and the cosine squared to get cosine cubed. Oh man, is that going to help? Well, let's just do that. I'll follow my own rules, keep my pencil moving. Okay, so as you can see, while we haven't done anything illegal, this has kind of taken up some time, but let's just keep it going. I'm noticing that these two terms both have a sign in the denominator, so I'm going to combine those numerators. We're going in circles here. I notice that there's a cosine in both terms in the numerator here, so I'm going to factor one out. And now you'll see that what's in parentheses there on the left-hand side is actually a trig identity. You know from your fundamental trig identity that 1 minus cosine squared equals sine squared. Move that over. So you know that 1 minus cosine squared theta equals sine squared theta. So we can plug that in at this point, and you'll get cosine theta times sine squared theta over sine theta plus cosine theta sine theta equals 2 sine theta cosine theta. Alright, we've taken the most roundabout way that we can for this problem, but it's still going to work. As long as we don't do anything illegal, it's still going to work, because one sign in the denominator cancels with one sign in the numerator. And you have cosine theta sine theta plus cosine theta sine theta equals 2 sine theta cosine theta. Of course that's true because the left-hand side has two like terms. You combine them, and multiplication is commutative, so cosine theta sine theta is the same as sine theta cosine theta. So that is absolutely true. It took a long time, it took a lot of steps, but we kept our pencils moving, and eventually it worked out. Now, if you go too far with one of these problems, it's going to become more and more likely that you'll make an algebra error somewhere. So if you're not doing these trig identities in a few steps, it might be a good idea to go back and say, well, maybe I can do something slightly different. But this is a testament to moving your pencil, keeping it going. If you don't make any mistakes, you'll get there eventually.